All right, so factor the bottoms. There's nothing to factor in the bottom. Find your LCD. All right, so find my LCD. So I work from my left to my right and take each thing once. So I get an x plus 2 and I get an x minus 2, and I've already got an x minus 2, so I don't take that last one. All right, so now here's the new stuff. Stack the LCD on top of each fraction. And that's what I mean by stack. And I don't know really anybody that does this because it's extra writing and they have other shortcuts they use. All right, so stack it. Now, reduce the fraction. So what's going on here is in each fraction, this is the top and this is the bottom. So we reduced fractions in all of the last section, all three parts. So I have an x plus 2 and an x plus 2. I have an x minus 2 and an x minus 2. I have an x minus 2 and an x minus 2. And what you should notice is that all the denominators are gone. That's what you wanted to happen. So now write it with what's left in the top. So you have a 1 times x minus 2. Then you have a plus, and you have a 5 times x plus 2. Then you have an equals, and you have an x plus 3 and an x plus 2. All right, now I'm going to slow down here for a second. This green came from here and there. What's left? This blue came from here and there. Again, what's left? And this purple came from here and there. What's left? All right. The denominators are all gone. That's what I wanted to happen. Short explanation for a super long concept. I am multiplying everything by the LCD, all right, by the same number. It's not a number, it's algebra, but I'm multiplying it by the same number if it was just fractions. It eliminates all the denominators, and it allows me to solve this equation in a much, much easier way than I would have to do if I did this a different way. All right? Now it comes down to algebra. So I have to distribute, do all those things, get it equal to 0, and then factor it probably. Okay? So I distribute this. I get x minus 2. 1 times that is going to be that. All right, then positive 5 times x is plus 5x. Positive 5 times 2 is plus 10. Be very, very careful with this sign here. It'll be a minus half the time. So then here, I've got to do my actual full distributions here. And I'm going to get x squared plus 2x plus 3x plus 6. All right, so I get all of that. It looks like a lot, and it's a bunch of stuff there. So I've got on this side 6x plus 8. Let me highlight what I did there. Those two went together. These two went together. On this side, I have x squared plus 5x plus 6. All right, so I've got that. Now, I've got an x squared in here. If I didn't have the x squared, I could just move things around and solve it like normal. But when I have the x squared, I have to get it equal to 0 so that I can factor it. So 0 equals x squared minus x minus 2. All right, so get it equal to 0 and then factor it, which is going to give me this. All right, and then that's going to give me x equals 2, x equals negative 1 as my two potential solutions. I'll write down need to check in denominators. All right, so some of you are like, oh my God, I'm never doing one of these. It's way too long. And it is long, okay? But these are the problems that when you do get one, they'll be worth a significant amount of credit, and you're not going to get like 3 of them, all right, on an assessment. You get 1, all right? Or you get a shorter one and a longer one. So I now look at my x equals 2 and my x equals negative 1, and I look back here at the original denominators. If I plug a 2 in to this first one, I'll get 2 plus 2, that's 4, that's fine. If I plug a 2 in here, I get 2 minus 2, that's 0. That's not okay. All right, I cannot get a 0. So that means that x equals 2 is not an actual solution, all right, because it makes the denominator 0. I take the negative 1, I look at it, negative 1 plus 2 is 1, okay. Negative 1 minus 2 is negative 3, okay, same deal there. So negative 1 is okay. So the answer to this is negative 1. Now, if you're wondering why it happened that I got that 2 when it actually wasn't a solution. When I multiply through by the LCD, I'm ignoring the fact that maybe it's a 0. All right, when I do this, maybe that's going to result in an answer of 0. That's why I have to check at the end. I'm not considering that it couldn't be that. You could, when you start, be like, okay, well, X can't be these numbers. And if it is, I'm going to get rid of them. All right, long process, take your time. Any little goof up in there makes it so it just doesn't work out right. And most goof ups will make it so that it's way harder to actually do.